All right, we're back. We're still on page 200. We might finish it in this video, hopefully, but who knows? So let's see if we can do this. So particle 1 travels from A to B in 8 minutes. Okay, so we can write parametrics for that, no problem. Particle 2, excuse me, travels from C to D, starting at the same time. Okay, starting at the same time. By the time it takes particle 2 to travel from C to D, if it collides with particle 1. All right, so we can do this in one of two ways. Well, we could do this in probably one of a million ways. Two ways that we've been doing it. So the first way, I'm gonna do the faster way, I think. So for particle 1, we'll have an x1 and a y1, right? And so particle 1 starts at 1, 2. X has to pick up 5 in 8. And then y has to pick up 8 in 8. And then it only is valid between 0 and 8. Okay. So let's say that particle 2 takes, should we say T2 to get to the intersection? Or total? T2 total, let's say. T2, let's say T2 total time. Right, so we can write parametrics for it. We don't know what T2 is, but we can say that x2, y2 is going to be 5, 2 is where you start, and then x has to lose 3 in T2 times t, and then y has to gain 8 in T2, and then the time will be 0 to T2, which we do not know. So now I can just solve this. I can solve a system of two equations and two unknowns. So the system will be, because they get to the intersection at the same time, we can do this. x1 of t equals x2 of t. y1 of t equals y2 of t. So why is this a system of two equations and two unknowns? So our unknowns are t and t2. We don't know what those are, but the calculator will find them for us. So let's go to the calculator and do that. And then while I'm on the calculator, I'll just like do the other method, potentially. So I added a calculator page. I should have added a graph page because that's the easiest place to put in parametrics. So I'm gonna say here, parametric. All right, 1 plus 5 over 8t tab, 2 plus 8 over 8, so that's just 1, so t, and then this should take 0 to 8. Now the other one that I'm going to put in, you won't be able to see it because we don't know what T2 is, and neither does the calculator. It's going to ask us for, a slider. Do we want to make a slider? And I'm going to say cancel, but like, I mean, you could say okay. It wouldn't make a difference, I don't think. So I just type those in. And do I want a slider? Nah, I don't want a slider. So you can look at it and you can just make sure that this looks right. This does look right to me, hopefully. So I'm gonna go back to the calculator and solve that system. Menu 3, 7, system of equations, two equations. So my unknowns are t and t2, which is weird. You could be using x and y. It doesn't make a difference. You just have to, in your mind, keep track of what everything is. And then the thing you enter looks weird. So it's x1 of t equals x2 of t. So maybe you're like, oh, they're on the same line segment because we do that. But then it's just a system of one, not a system. It's just one equation. Here we are using two different parametric equations. It's just t is one of the unknowns. T2 is inside of x2, y2, and it's unknown. We solve this. We get t equals 4 and t2 equals 8. So t equals 4, t2 equals 8. Therefore, particle 2 takes 8 minutes. Oh, they both take 8 minutes. That's weird. I don't know. I didn't do that on purpose or even try to. All right, so the other approach that I sometimes use on this is that I will create an x3, and I will say that this is just going to take 1 second to complete its journey. So in that case, it would be 5 minus 3t. I'm looking from C to D. 5 minus 3t, and then 2 plus 8t. And this one I know takes 0 to 1. So if I now solve this system, x3, y3, so let me think this through. What am I doing here? Oh, now I need to use dummy variables, t and v. Because they're not guaranteed to get there they do get there at the same time? They don't, no, these aren't guaranteed. What am I doing? I don't even know. Let me just solve this and see. T is equal to 4, v is equal, okay, yeah, I got it. So I can now do, so for particle 3, right? Particle 3 took 1/2 of a minute to get to the intersection point, and then it takes 1 minute total to make its journey. So that should be equal to the time that it actually takes particle 2 to get there, which is 4, because they get there at the same time. This is a terrible description, over like p, right? And then if we solve answer for p, we also get 8. So we get 8 either way. I'm gonna go back to the notes and explain that one more time, because that was a terrible description, even though I feel like it makes a lot of sense. And this is like the 3rd time I've done this particular method. So like, if you get it, good. If you don't get it, here's what I basically did. I created P3, which is going to be X3, Y3. This takes 1 minute. So that was just 5 minus 3t. And this was just 2 plus 8t. We solved x1 of t equals x3. Because we don't know, x3 is not going to get there at the same time. Like this, we know nothing about when x3 gets to the intersection point, so this is why we needed dummy variables. And then y1 of t equals y3 of v. So we ended up with t was 4, and then v was 1/2. Okay, so this, now you have to keep track of what each thing is. This is actually when P1 and P2 get to intersection, right? So that's the actual time they get there. And then this one is when P3 gets there. Okay, so far I think this is okay. And then what I did was P3 to intersection over P3 total equals P2 to intersection over P2 total. And then we know this is 1/2. We know this is 1. We know this is 4, and we can solve for this and get 8. Either way, no matter how you solve it, you're going to get 8. So P2 takes 8 minutes, and you know, I think I kind of hate to do it, but I'm going to break this into, I'm going to stop the video here, come back in the next one and do part 6, because it's like a little bit different, and I did not explain that part really well, so like, who knows? And sometimes when I take a break, I come back and I do a better job. So I'm going to stop this video here, come back in the next one, and then definitely finish this page, which I think will be like part 4 or 5 of this page, who knows? But anyway, I will see you there.